I'll be doing a video on predication and speculation support for IA64 architecture. The IA64 architecture, it supports predication. When we say it supports predication, we should know that every instruction in IA64 can be predicated. That is, every instruction. And for this, we have predicated registers. These predicated registers, they are placed in the lower 6 bits of the instruction field. These predicate register, they are set using the compare or test instructions. The compare instructions, as you know, it is comparison. And it also has 2 predicate registers. Now these 2 predicate registers, they act as destination. The 2 predicate registers, they are a result of comparison. Result of comparison and the complement. Or you can also tell that it's a result of logical function. Your logical function is your and the or and the complement. The speculation support, it also deals with the deferring exception. Now, deferring exception is something where you provide extra bits. Extra bits, I can also call them as poison bits. Poison bits. For example, for your GPRS, these bits are called as NAT. NAT means not a thing. And these extra bits are the poison bits. Whatever we are providing to the GPRS, it makes the GPRS 65 bits wide. Similarly, for FP registers, these are obtained using a special value, that is NAT val. Whereas it's the same, but your val stands for NAT value, that is not a thing value. We can tell that the speculative instruction, we have 2 different types of instruction, that is speculative and non-speculative. Your speculative instruction can be the load instruction, and your non-speculative, I can tell it's a store instruction. Only the whatever value that is being generated, that is NAT val, it is only for speculative instructions. So what happens if it's a non-speculative instruction and it generates an NAT val? So what happens is, whenever a non-speculative instruction generates, if it generates NAT or NAT val, it will generate an exception. And this exception is unrecoverable. Now let's talk about memory referencing. Memory referencing is done using advanced loads. Now, what is advanced load? As we always tell, advanced means a level higher. So we can tell that advanced load is a load that has been moved above store instruction. Now, about the execution. Whenever you execute a speculated instruction it generates a new entry in the special table. And this new entry is called ALAT. I don't know the full form of this ALAT, but all I know is it's called as ALAT. What does this ALAT do? As this ALAT is an entry, we can say that it stores the register destination of the load, because we know that speculated instruction is a load instruction. So what it does is it loads the instruction. So it stores the destination of the load. And it also stores the address of the memory location from where it is being accessed. Now for the non-speculative instruction, whenever a non-speculated instruction, it uses a value which is there in the advanced load, a check is required. That is, when it takes a value that is there in the advanced load, we need a check. And there are two kinds of check. So the first check, this is an instruction. And it causes the data to be reloaded from the memory. That is the first check. The second check, it specifies the address that is used to execute the load. Re-execute, not execute, re-execute. That is address So we have two kinds of check. The first check is an instruction which reloads from the memory, and the second check is an address that is used to re-execute the load. So thank you, and this is all which is there in support, that is speculation support. Thank you.